All right, so we're going to take a look at knowledge check 12.3.1. To do this, we're going to use two different packages, the tidyr package and the dplyr. So within the tidyr package, there is a table or a data frame that's called table 4b, and we're going to look at this. And the question we have here is this data untidy? If so, why? So when we look at this, we have three columns. We have column country, and then we have two columns where the value or the column name is the year that these values were recorded, and then the actual values represent the population. So when I look at this, I see that we actually have 3 bits of information: country, the year, and the population. But we have the year variable listed as the column names. So I'd say this is untidy. We'd prefer to have a data frame that's got 3 columns: country, and then a year column, and then a population column. And we'll look how we can do that here in a second. But before we do that, we get this question: compute the sum of the values across the years for each country. We can do this. We could still do this in its current form. So let's go ahead and do 4b, and we're going to use mutate. So what we're going to do is actually add the values in these 2 different columns. And so we're going to say total population equals 1999 plus 2000. Now, we can't actually do it like this, because what's happening here is in R, in the mutate, it would simply add 1999 plus 2000, and our column would be 3999. What we mean to do is refer to the column names that are the numbers 1999 and 2000. So to refer to the column names that are integer values, we actually use backticks. And now when we run this, we see we actually are computing the total. Now we have a problem here in this 3rd row. And the reason for this is because integers are stored in certain bit size, and we're limited on how large of integers we can actually add up. So what we can do to get around this, whenever you run into this where you're adding 2 extremely large integer values, what we can do is coerce these columns to be numeric or floating point, like decimal values, and we can actually store larger data values in floating point values than we can in integers. So now we see we get the computation for that 3rd one. So that's kind of a unique edge case just to be aware of. All right, so we've computed the total population across for each country. So now the next one is pivot this data set so that it is tidy with the year values represented in their own column called year, and the values listed in their own population column. So to do this, we can use one of the pivot functions. In this case, we want to use pivot longer. So let's go ahead and look. And pivot longer takes a lot of different argument types. But what we care about here is, first we can go table 4b, and then pivot longer. And we want to say, well, we want to pivot the columns, and we want to do, we got to use backticks, 1999 and 2000. All right, we want to pivot those columns. And what we want to do is say the names of those columns now become a column that we call year. And then the values, which values 2, becomes a column that we're going to call population. And now you see we have a tidy data frame that has our 3 columns of interest: the country, the year, and the population. All right, so now it says, using the pipe operator to chain together a sequence of functions, perform number 3, and then compute the mean population for each country. All right, so let's go ahead. We're just going to take the same code, because what we want to do is pivot our original data frame into a clean data frame like we did above. And then we want to get the mean population for each country. So we need to first group by the country column. And then now we can go ahead and summarize, and we can get, I'm just going to call this average population equals the mean of the population column. And now we see we have our average or our mean population for each of the countries.